Okay, here's a video that we are looking at expanding binomials. We're not going to do this probability one yet, but we're just looking at expanding binomials. Again, it's something that's looking at a pattern, which is similar to what we've done before when we looked at permutations and combinations. Those are examples of patterns. And so when we're expanding binomials, we want to find a pattern and then use that to help us expand binomials. What I'm talking about expanding binomials is something like this. If I have x minus 3 squared, I could write that out as x minus 3 times x minus 3. When I say expand, what we mean is to multiply it all out. So x times x is x squared, x times negative 3, negative 3x, negative 3 times x, another negative 3x, negative 3 times negative 3, positive 9. So when I'm done, I'm coming up with x squared minus 6x plus 9. So what I'd like to do is to be able to go from this to this with not all of this stuff in the middle. Maybe I'll have some stuff in the middle, but like if you think about this one, x minus 3 times x minus 3 times x minus 3 times another x minus 3. And if you were to FOIL that out, and then take what you get from that and FOIL it all out with this one, we're talking a ton of work. So what we're looking for is a pattern to see if I can take a binomial and expand it with whatever the exponent is there and come up with this fairly straightforward. I've done a couple here, and these, I think lots of textbooks have these in them. But if you take anything raised to the 0 power, of course that's 1. If you raise something to the first, it doesn't change it. It's just a plus b. But here's where we're starting to look for a pattern. So if I have a plus b squared, this is what it comes out to. Take a look maybe at the letters. So I've got an a squared, then an a, and then no a's. And then I have a b squared, a b, and then no b's. See if that pattern follows here. A cubed, a squared, a, no a's. B cubed, b squared, b, no b's. You've seen the patterns with the letters. So this number here sort of indicates what this power will be, and it'll be whatever the power of is in this last slot over here. Same thing with this one. So a to the 4th, cubed, squared, to the 1st, to the 0. And then b's, or this last term, goes the other way. Okay, so hopefully you're seeing some kind of pattern there. Another pattern that you might look for is one that has to do with the numbers. Here I've got a 1, and then with these two, there's no number in front, so we assume it to be a 1. So there's two 1s, and then here I've got a 1, 2, 1, and then I have a 1, 3, 3, 1, and then a 1, 4, 6, 4, 1. Are you seeing any kind of pattern happening there? I'm sort of seeing that this number always seems to go up by 1. So does this one here, like 2, 3, 4, 5. But how am I getting a 6 in here? Let's take a look at something called Pascal's Triangle, and we'll come back there. Pascal's Triangle is one that's used for a number of different things, but the way you get another row from Pascal's Triangle is by adding the two things above it. In a Pascal's Triangle, the first term is always a 1, so I'm going to always have 1s over here. And then what I have to do, and then what I have to do is add these two numbers here, and that gives me this term. And then this will be, again, a 1 at the end over there. And then I add these two, so this would be a 3. Add these two, this would be a 3. So this 1, or this would be 0. This would be something to the 0, to the 1st, 2nd, 3rd. Now this next one, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then a 1 at the end. And then my next row would be, what would this be? 5, and then this one a 10, a 10, a 5, and a 1. So what I can use is I can use this pattern to help me, if I wanted to help me when I'm expanding a binomial. See the numbers there, 1, 5, 10, 10, 5, 1. I think that's the one that we just got right down there at the bottom. So I'm wanting to use it in conjunction with the patterns of the letters and the pattern of the numbers out front. I want to be able to find a pattern where I could multiply this all out or show the expansion of that without having to FOIL all of them. So let's take a look at a couple examples. Just generally, this is something that you could write for a pattern for expanding a binomial. If I have any terms like this raised to some exponent, what you're doing there is you're getting the sum, that's what this is, of plugging a 0 in everywhere you see an n here, and plugging in k would be whatever term you're looking for. So, and you plug that in there. So you could use this formula to help determine a specific term, or it actually is the whole expansion. Let's try some actual examples and see if we can put all this stuff together. So what I'm saying is if I have a plus 4 squared, I can sure multiply it out like this to get that. Or I can say, to get any term, what I want to do is, like if it's a plus 4 squared, I'm going to have a as a squared, the first one, and then 4 squared, 16 will be the last one. And then to get the middle term, what I do is it'll be one of these and one of those, so a to the first, 4 to the first, and then you multiply all this out. This thing here, we didn't talk about this yet, but remember back to this Pascal's Triangle. To get any one of those terms there, what you can do is use combinations or a combination formula to figure out any one of those terms. So again, let me show you here. So this, if this is a 2, then to get the first coefficient, you go 2, choose 0 on your calculator. Then the next one, the coefficient be 2, choose 1, then 2, choose 2, and you're done. Let's try another example. Hopefully this isn't getting too confusing. Okay, so here I want to figure out the binomial expansion for this. So what I'm going to do is, since this number's a 4, I'm going to go 4, choose 0, and then I'm going to take this first term, which is 2a, and it gets raised to the 4th power. Then I'll take this negative 3, make sure you bring in the negative, and raise it to the 0 power. Now, if I multiply all this stuff together, what I get is whatever the first term, like if you were to multiply this, you get term plus another term plus another term, etc. If you multiply all this stuff, what you're getting is that first term right there. So 4 choose 0 is 1. 2a to the 4th, you'd have to raise 2 to the 4th, that'd be 16, and a to the 4th, and then negative 3 to the 0, anything to the 0 is 1. So if I multiply all that stuff together, it looks like I'm getting 16 a to the 4th. That's my first term. That goes right there. Okay, that's first term. Second term, I'm going to go 4 choose 1 this time. And then this one, it'll be 2a. Rather than being 4, like we said on that one of those early slides, this will be a 3. And then the negative 3 will be to the first power. Okay, 4 choose 1 is 4. 2a cubed would be 8. 2a all cubed would be 8a cubed. That's what I get from this part. And then negative 3 to the first is negative 3. Now multiply all this stuff together and you'll get this term right there. So 4 times 8 is 32. 32 times negative 3, negative 96. So this term right here is negative 96a cubed. Okay, now the next one. 4 choose 2. 4 choose 2, gee, I don't know what that is. Let me grab my calculator here. Come on, calculator. My license is almost over. Come on. No, continue with my trial. Okay, what did I say? 4 choose 2. So 4 math over to PRB choose 2 equals 6. So it's 6. Gee, I probably could have got that from over on one of these charts here. 4, and then 6 was my next one. Okay, so 4 choose 2 is 6. Well, this I need to do. So it's 2a, 4, 3, this one has to be a 2, and then negative 3, 0, 1, this one has to be a 2. So 2a squared, 2a all squared would be 4a squared, and negative 3 squared would be a 9. So now I have to go 6 times 4 is 24, and 24 times 9, whatever that is, 36, 3, 216. So this will be 216a squared. So that is my third term right there, 216a squared. And you just keep going with that same idea. Okay, and so there's going to be 4 choose 3, and lastly you'll finish with a 4 choose 4. Okay, and do the accompanying things beside it. And once you finish all of them, then you just write them all together in one long polynomial. And that will be the binomial expansion of that expression right there. So maybe just try one more, just to make sure you're getting it. So here I have a plus b all to the 7, and I want to figure out the binomial expansion. And I guess I could figure out the whole thing, but sometimes maybe they'll just ask me for one term. So how about we go with the fourth term? Okay, so to get the fourth term, I know I have to go 7 choose 0, and then 7 choose 1, 7 choose 2, 7 choose 3. So this one right here will be my fourth term. Okay, this one is my fourth term. Okay, 1, 2, 3, 4. Now I just have to fill in the other stuff. So this one here would be a to the 7th, b to the 0. And then this one will be a to the 6th, and b to the 1st. I should put that 0 on the outside. And then this one would be a to the 5th, b squared. And so the term that I'm looking for is a to the 4th, and b cubed. Notice that these things always add up to that number there. Okay, so now I have to just do 7 choose 3. So 7, 7, math, choose 3, go, 35. Okay, so 7 choose 3 is 35, and then a to the 4th, b cubed. That would be my fourth term of that binomial expansion. Okay, hopefully that helps you out with binomial expansions. You probably want to practice quite a few of those just to make sure you're understanding the pattern.